Hey Cacher, Derek here, Bake Six Clan. Today we are going to be diving into some of the questions that I've had as we have been doing this build for the Smart Cache, and I had to ask Dave some questions and he sent me his answers. Let's get started. Alright, so in this build that we've been doing of the Smart Cache, I've had some questions on why are we putting certain components in and doing different things. And I'm sure these are some of the same questions that you've had as we've been doing this build. So I've sent email to Dave and we've talked back and forth, and I've got his answers on some of these questions. I mean, one of them is an obvious question, is why are we using an Arduino or a Nano? And here's his answer. It's simple and easy to use for a geocache. A microcontroller is used because you can put a lot of complexity and operating logic in a very small space. And it is made with lots of inputs, outputs, analog measurements, times, etc. to easily interface with buttons and lights in MP3 players. The Arduino family of products is widely used, well supported, and very inexpensive to purchase. It can be coded, and the code can be uploaded over a USB cable from any computer. The Nano device is used here because of its small size compared to an Uno and a low cost. So just simple is that it is because of you can do so much with it, and we're wanting to have that interactivity to do it, so that's why we're using the Nano on this one, because also it's a lot smaller and it is cheaper than the Uno, so you can do that really well. And we don't want this cache to be really big, and we get the same things out of the Nano that we could with the Uno. Now my next question that I asked is, why have the cacher bring AA batteries? And Dave's answer is, it's the simplest way to power a smart cache. Caches can be powered internally and can be designed for long caching lives before ever needing to change the batteries. But that adds complexity to the design. Switches can be left on after departing by the cachers. Door switches can be misaligned and not turned off or turned on. The one downside is the potential for corrosion and mechanical abuse of the battery holder contacts over time. So I was like, okay, so yeah, I can understand. Sometimes it is nice to have internal batteries and the cacher doesn't have to bring anything and they can just do all the activity there. But you do risk, if you don't have a way of it powering off or doing different things, that it'll run those batteries down. And so when the next cacher comes, it can't be found because it's not working because the batteries are dead. All right, so then my next question was, why have the cacher bring or need 3 batteries for this one? And this is Dave's answer. A trade-off of simplicity. For the cache electronics, 6 batteries would be ideal. It would power anything in the cache and provide more than 9 volts of power, optimum for the builder. But who wants to provide 6 batteries? The holder would take up a lot of room. You could use a 9-volt battery, but besides the challenge of getting the cacher to bring them, cost and oddity of use, even fully charged, and often they are not, they really lack the capacity to power any cache that has even a medium use of power. In our case, we have MP3 player clips, an audio amplifier, so that will drain a battery quickly. 3 batteries provide at least 5 volts and often lower, 3.6 to 4.8 volts. So how does it run the electronics, you ask? We're using a DC-DC converter that takes a lower voltage and boosts it up to 5 volts. The trade-off is it will draw more current, juice, from the batteries to do so. But AA batteries have a lot of capacity and will provide all the current needed to operate the cache. If you have a DC-DC boost converter, why not use 2 AA's or 1 AA battery? Well, we could, but as you take a smaller voltage, potentially 1.2 volts, and boost it to 5 volts, the current draw will be dramatically higher, giving the higher power demand on the cache and the potential for long play. We opted for a trade-off of simplicity. Take the middle ground of 3 batteries. That is why in this one we went with the 3 batteries, is because we could go lower and using that converter there or the DC-DC boost to bring it back up, but if somebody doesn't get this right off within a few minutes, it could kill their battery and then they have to go get another one. So with 3, it's not going to be drawing as much, even though it's getting to that. So it just kind of makes it to where it needs to be. So that's why we're using 3 on this. Next question is, why use the electronic release latch? And once again, here's what Dave's answer was. Mechanical simplicity. Given you can reliably activate the latch release mechanism, it is unlikely to cause issues due to its simplicity as opposed to servo motor mechanisms. The only potential downside is corrosion. It's not really designed for outdoor usage, so it needs to stay as dry as possible. Use of a combination lock is the most reliable, good quality outdoor lock. I mean, we've seen those that aren't really good and they have some issues. So combination lock is the most reliable, with the cache solution providing the combination. But it's so much fun to pop open a door and have a resounding clack. And I completely agree with Dave. I knew when we started talking about this, I wanted one of those release mechanisms, the latch, because I just really love the way those just sling it open, and it just is really cool. And when you see that actually open, it is so amazing. The door flies open and has that clack. It can kind of startle you just a little bit, but it's a lot of fun. So, all right, so then my next question was, why have internal batteries and cache or bring batteries? Because if you remember, there is another battery pack in this. So, and here is Dave's answer. A balance of reliability against simplicity. The door latch needs a lot of power to operate for a very short duration, over an amp, and it requires a higher voltage than the rest of the electronics. The latch says it works on 6 volt, but batteries will drop dramatically in voltage when trying to source more than an amp. We want 100% accuracy that the door will open every time. The simplest way is to just put a block of 6 AA batteries in the box and use them to open the latch. The current used to open the latch is high, but it will only be applied for a fraction of a second. The battery should allow many thousands of openings before needing to be replaced. Alright, so that's why we wanted to have the 2 separate sets of batteries. The 3 batteries of the AA that the cacher brings will power the Nano, and really the 6 AA batteries really just power the latch itself because it requires that much more power. And that's how you get around that, because you can't fire that latch through the Nano itself. So, and that brings us to the next question. Well, why do we need a relay? And Dave's answer was simplicity and isolation. The latch needs more than an amp to open, and that is worlds higher than a Nano can provide. We also are switching it open using a battery that is 9 to 10 volts, which would destroy the Nano. Best to keep these 2 systems in different camps. The relay module comes with inputs that will tie directly to the Nano and will completely isolate the latch circuits from the Nano, as well as handle the amps needed to open the latch. So that's just a reason, keeping it separate. Like I said before, that's why we have the 6 batteries for the latch itself, and then we have the 3 batteries to power the Nano. Like I said, the Nano will not power the latch itself because it does require a lot more, and it keeps it separated, and the relay in there keeps it from backfeeding some into the Nano and blowing it up. So yeah, because otherwise every time a cacher would find it, I gotta go replace the Nano every time, and that would get really expensive. Then my next question, why do we need the big diode? And Dave says, reliability. There is a large diode placed across the drive coil of the door latch mechanism. It is called a suppression diode. Without it, havoc reigns, relays die, and batteries suffer. The door latch contains an electromagnet. When energized by our 9 volt and more than an amp of current, a strong magnetic field is formed from the coil inside, which pulls on a metal core to activate the door. All good. The problem with any coil is when you turn it off. When the relay contacts open, the magnetic field collapses on the coils, and all that energy creates a very high negative current on the coil. That can create a high reverse voltage across the coil. That can burn out the relay, contacts over time, stress the batteries, etc. Good news, just place a diode across the coil that allows a reverse path for this current to dissipate. Eliminates all the hurtful current from the coil. You might recognize there's another coil here, the relay. The relay module already includes a suppression diode on the assembly, so no need to put one there. So if the relay didn't have already one of these diodes in there, we'd have to put another large diode. But that's why we had to add that other diode in here. So once again, it doesn't backfeed into it. Because remember, a diode works like a one-way door. Okay, the current can go one direction through it, but it can't go the other way. And that's why we did some of these things in this. Or actually, not some. This is why we did this build the way we did. And I really do appreciate Dave for answering these questions, because I know I didn't have the answers, and that's why I love working with Dave on this, because he helps me to understand what's going on and why we're doing this the way we are. Now, I'm sure you may have some other questions, and I may not have the answer, but I'm sure that Dave may have those answers. So if you would like have some questions on how we're doing this build, go ahead and put those questions down in the comments. I would love to see it. And if I don't have the answer, of course, I'll get with Dave. But thank you for joining us today. I hope this has been helpful. I hope this helps maybe spark some more interest and not scare you quite as much of being able to do these smart caches. But I really do hope you've enjoyed this. Now, any of these components that I've been using on this, I do have links down in the description, so check those out. And those are affiliate links. And anything that you click on that will help the channel, and I really do appreciate it. But hey, I really hope you've had a good time on this and hope that you've learned a lot today. But don't go anywhere. Go check out another one of these stories just right over here and find the story behind the cache.